Yeah, today I'm going to be talking about Swift, which is a relatively new language from Apple. It was only introduced to the public last summer, well, summer of 2014. And then just a few months ago, Apple open sourced Swift. So now the compiler is already available on Linux, and there are plans to bring it to Windows as well. And it's really cool. They're not just open sourcing the core compiler itself, but also a lot of the foundation libraries that go along with it. And so there really is a full implementation of Swift available for Linux right now, which is pretty cool. If you're interested, the notes for this talk can be found at git.io/grokswift with a capital G and a capital S. You can follow along there. We'll put a link in the minutes too if you want to check that out later. There are going to be a couple code samples that I mentioned. And if you go there, you can just click on a little link and open the code sample in IBM's Swift Sandbox, which is pretty cool. It's a little browser-based environment where you can edit Swift code and then click a button and it'll run right within your web browser. So that's pretty cool. So yeah, that's available if you are interested. Let's see. So let's get started, huh? If my remote decides to work. Which it may or may not. It's thinking. Maybe?
Would you like me to sit up there and...
I don't know. I hope not. Yeah, maybe if you want to sit up here. Just in case.
Okay. Is it spacebar, right?
Yeah, I think so.
Okay, just point it.
All right, so whenever we start talking about a new programming language, it is tradition in the style of CNR to start with Hello World. So I thought that's where we would start with this. In Swift, Hello World is just this simple. Print Hello World. This is, in fact, a complete Swift program. You'll notice that we don't need to declare any main methods. We don't even need any semicolons at the end of the print statement. In Swift, kind of like in Python, for those of you familiar with that, anything that you put in the global scope will be executed when you start the program. So, obviously this doesn't prohibit you from using things like objects and functions in Swift. But this is a complete Swift program. And that's pretty cool because one of the design goals for Swift was for it to scale from just a simple scripting language all the way down to low-level operating system calls. They want for the entire stack to be able to be written in Swift. So that's pretty exciting. Another cool thing about Swift is that when you declare a variable, you can just do it with the var keyword, or for constants, it's the let keyword. We don't need to declare type information. Like it's not int my variable or double my variable. It's just var. This is similar again to Python where we don't need to declare types, or JavaScript if you're familiar with that. But the cool thing that makes Swift different is that unlike JavaScript and unlike Python, the variables are actually statically typed. So once we've declared my variable and set it to an int, we can't then change it to a string or something later. In this example, let implicit integer equals 70. Implicit integer is now an int. We can't write a string to it later or anything like that. And implicit double is a double because we put the little decimal point there. It figures out what type we mean when we set something. Now, if we don't want to do that, if we want to just set up a space for a variable and we don't want to declare it right away, or we want to be extra sure that it's a double or something, we can give it this type information. But you see, it's almost more clear to just write the code this way instead of with the extra type information. So this is what I was getting at earlier. Python is a dynamically typed language. For the folks that are big on Swift, they would say that it is not safe typing. So we can set my variable equal to an int 42, and then my variable is an int, and we can increment it, decrement it. But then in the very next line of code, we can give my variable a string, and okay, I was an int before, but now I guess I'm a string. That's totally fine. And it seems convenient when you're a novice, but it can lead to an awful lot of problems down the road. And so in Swift, this code will not compile. Once you set up my variable to be an int, you can't change it to a string later. It is safely typed. It is statically typed. Once the types are set, they cannot be changed. So here, I just wanted to compare the syntax of Swift to Java and Python a little bit. So here at the top, we have some Java code, and I believe I took this out of the B11 textbook. We're just kind of looping through an array. We've got a little condition, and we either add 3 to the variable or 1, depending on what the team score is, and then we print it out. You'll notice the enhanced for loop syntax from Java, which turns out Swift has as well. But where in Java we need to say that score is an int, Swift already knows that it's an array of ints. We can leave out that redundant information, and we can just say for score in individual scores to loop through. But otherwise, the code looks very, very similar. You'll notice also the lack of the semicolons at the end of each line, and when we print, we can just use the print keyword. We don't need the system.out.printf. Get rid of a lot of the extra verbosity. Here's some more Java code. We've got a for loop. We're going to start at 0, and we're going to work up to and including 4. We know that it's including 4 because it's while it's less than or equal to 4, and then we're going to increment. We don't need to do that in Swift. Swift version 1 and 2 still supports this old C style of for loop syntax, but in version 3 of Swift, they're going to get rid of that. They said, we usually use that for dealing with pointers and arrays, and we don't really want to deal with that in Swift. So this is how the for loops are going to look in Swift. It's just for I in 0.4 is the same as Python's range operator, and it means I want to start at 0, and I want to go up until 4. And so functionally, both of these examples do the same thing. It's just this one is a little bit, I think it's a nicer syntax. It's certainly less verbose syntax. So I was talking about the Python range operator. Let's take a look at that. Oh, sorry, before we get to that. Again, both of these are the same. This is just a different style of range operator. When we say ... less than 5, that means up to but not including the number on the right-hand side of the range operator, which we'll recognize from Python when we have for range 1, 5. This means we're going to start at 1, and we're going to go up to but not including 5. So if you don't like the syntax, as they say, I think we can safely, in the parlance of our times. So hopefully I've convinced you that Swift is expressive. Now I'd like to talk a little bit about what makes Swift safe. So like I was saying, one of the biggest problems with dynamically typed languages are, you'll start with the variable being an int, and then maybe some function might change it to a float, or it might not, or maybe it'll end up being a string later. And it seems like, well, that just makes life easier, doesn't it? But in fact, a lot of the operators can take on different meanings with different types, right? So when we have the plus operator, if we have a string plus a string, then obviously that's there to concatenate the two strings. But if we have an int plus an int, we don't want to concatenate, we want to sum. And so it's really, really important when we're programming that we are able to predict what type a variable is going to be. And Swift will allow us to figure that out at compile time. If we're treating an int as a string, it won't compile the program. It gives us that early opportunity to bail out. Furthermore, Swift is really trying to get away from pointers and manual memory allocation. So like in C and C++, we do a lot of sending pointers around. And, that was necessary at the time when computers were very constrained for resources. But then, in the 90s and since then, languages like Java, like C#, like Python have said, there are better ways to deal with objects than just passing pointers around. And so while you can still get at the underlying pointers in Swift, you really don't need to for most high-level programming. It will figure that out for you. Now, unlike Java and C#, languages that have a garbage collector, Swift does away with the garbage collector. I guess I don't want to talk about it too much because it's really a more advanced concept. But one of the problems with the garbage collector is that it can run at unpredictable times. So like in Java, you've got an object, and then you're done with it. And then you get another object, and you're done with it. You get another object, and you're done with it. And you're just kind of setting these off to the side. And then periodically, the garbage collector comes through and says, oh, is there anything here that's not being used? Okay, we'll free up this memory. We'll free up this memory. That's good. That's necessary. The problem is that we don't have any control as programmers of when the garbage collector is going to run. So if the garbage collector decides that it needs to run when we're doing something that's really computer intensive, it's going to cause the program to slow down. And that's no good. So the way that Swift gets around that without resorting to manual memory management, where the programmer has to manually allocate and then deallocate the memory, is they use a concept called automatic reference counting, or ARC. And this is a technique that was pioneered by Apple maybe 3 or 4 years ago, where whenever you create an object, it notices that there is one strong reference to that object. And then anytime you pass that object to a function, or make a copy of it, or pass it off somewhere, it'll say, okay, now there's another strong reference, and another strong reference. So I know this object has 3 strong references. And then once the function is done with it, it'll decrement that number and say, okay, now there's only 2, now there's only 1. And as soon as it notices that the object does not have any strong references, then it will deallocate that. The cool thing there is that all of this can happen at compile time. It doesn't need to happen at runtime. So it doesn't take any extra resources away from your program, which is cool. And that kind of leads into the last point, that Swift is fast. One of the reasons that I am most excited about Swift is that Swift is a language with, as we've seen, very high-level syntax, very friendly syntax, but it compiles like C. Swift was written by a programmer by the name of Chris Lattner. Dr. Lattner got his PhD in optimized compilers for pointer-heavy languages. So he knows how to write a good compiler. And it's not just that Swift has a good compiler behind it, although I think it does, but because he is a compiler guy, that has influenced all of the design decisions that go into creating the language. So whereas a language like, I hate to kick it while it's down, but if we look at a language like JavaScript, which is kind of the typical example, JavaScript was written by a guy by the name of Brandon Eich in a weekend because they wanted Netscape to be able to do cool stuff in the browser. So, well, here's a syntax that looks kind of like Java, and it's pretty cool, and we'll figure out how to run it later. So after the syntax was already formalized, and years later, for several years, JavaScript was just kind of a nice little language to be able to make sure that somebody's email address is correct before you submit a form. But then 10 years later, in the early 2000s, Google started doing a lot of cool stuff with like Google Maps, with Gmail, and people said, oh, this JavaScript, it's not just a toy language. We can actually build cool things with it. But it was never intended for that, and so it was very, very slow. And so Google has come up with their V8 JavaScript engine. Apple has their own engine. Microsoft now has a really cool JavaScript engine. But it's taken us 20 years and literally millions of dollars to get JavaScript to be performant. And with Swift, we don't want to do that. We're not going to include anything in the language unless we know how to write a compiler that can do this thing quickly. And so they've excluded from the language anything that would be difficult to write a compiler for. And so I think that is the reason that I'm most excited about Swift, whereas I've typically been down on higher level languages like Java, as some of you have heard me talk at length about. So I guess that's about all I have, except to say that, like I mentioned earlier, Swift started at Apple, and for the first year of its existence, it was just the language that was going to be used for writing iOS apps and Mac apps. But a couple months ago, Apple open sourced Swift, and immediately IBM jumped on board and started using Swift for server-side apps. IBM is very excited about Swift and is actively looking for Swift programmers. IBM has a cool Swift sandbox that I mentioned earlier where you can type code and then it will run with IBM's Swift compiler on their servers and then display the output to you. So I really do... The goal for Swift, like I mentioned earlier, is to be able to scale from low-level operating system code all the way up to high-level scripting. And I do think that of all of the languages that have come out over the past several years, Swift has the best shot at being able to achieve that goal. So I'm very excited about it. I like Swift a lot. I've done some of the programming challenges in Swift. It's a nice language to work with. And I would encourage you guys to experiment with it a little bit if you have some time. So I guess I'll take questions if anybody has questions. I'm not an encyclopedia on Swift, but I'll try and answer any questions as best I can. Yeah, Diego?
In a few years down the road, do you see Swift being like one of the main languages taught at universities or colleges, or even high schools as they start?
There are a couple of colleges, and I don't want to drop names because I don't have it in my notes, but I know that there are a couple of colleges that already have programming courses in Swift. Like we've seen from the syntax, I think that Swift is a very forgiving language. Like, in Java, as we all remember, if you forget a semicolon, your program just breaks. Nothing happens. And sometimes it's so frustrating to hunt down, that comma that's out of place or something. And I think that Swift nicely does away with a lot of that. So I think that Swift certainly could be used as somebody's first programming language or somebody's introduction to programming. And then, hopefully, if we can use it all the way up through, the operating systems and the really advanced programming stuff, they could just keep using that programming language and build on that. Yeah, Gabe.
So, do you think, like, say in a couple of years, not only will universities use it, but developers be using it a lot more than other languages? And if so, do you think like it'd be a really good idea, since we know about it now, start learning it now, and it'd be good for our portfolio resume to put on?
There are two questions there, and I'm going to answer them separately. So I think that, yes, Swift will be the language going forward, at least in the Apple ecosystem. So up until now, Apple has been all about Objective-C, which was a language created by Next back in the late 80s. So if you wanted to write iOS apps or Mac apps, it really had to be Objective-C, unless you wanted to go through some sort of weird compatibility layer that would, translate your Java code into Objective-C or something like that. And Apple is totally committed to Swift. They've made that very clear that Swift is going to be the next language for iOS and for Mac OS 10. So certainly, if you want to do any of those apps, I would learn Swift rather than trying to learn Objective-C first. As far as your second question, would it be good to learn Swift? Yes. Yes, I think it would be very good to learn Swift. There's kind of a joke that Swift has been out for about 1.5 years now, and there are lots of firms looking to hire Swift programmers with at least 10 years of experience. But this is a kind of cool opportunity for us to get in on the ground floor. And Swift hasn't yet celebrated its second birthday. That's coming up in June. And so you really would be able to say that you've been programming in Swift for almost as long as it's been around. Does that answer your questions? Cool. Any other questions?
Yeah, how can we check out like Swift? Or like, what do you check out?
I think the easiest way to dip your toe in would be with that IBM Swift sandbox, which I was talking about. And there are some links to that from my talk notes, which I'll put on the website later. Unfortunately, with that, you can't do anything that involves like getting user input and stuff. But like I say, right now, there's not a Swift compiler available for Windows yet, unfortunately. It's coming. It should be coming later this year. But right now, if you want to use Swift on your own machine, it's got to be either Linux or Mac OS 10. Yeah?
Can I add something to that? You might have already answered that, but You can find like library and documentation on that website. The
Oh!
Sandbox
Yeah. Swift.org is the official website of Swift. I'm pretty sure it's .org. And they have a lot of documentation. Apple has 2 free ebooks available. One that's talking about the Swift programming language itself, and another that's talking about how to call into Apple APIs from Swift. Previously, you could only get that from the Apple iBooks store, but just a couple months ago, when they open sourced Swift, they made that book available as a PDF for download on the Swift website. And that is a wonderful book. Even if you're only a little bit interested in Swift and not a super technical programmer, I think you could get through the first couple chapters in that book and get a good feel for what Swift's goals are and what it's trying to accomplish as a language. That Swift programming language book would be the first place to start.
So since it doesn't allow input as of now, is that what you said?
Well, I mean, you can do user input with
Oh.
Swift, but you have to be running it on your own machine for that.
Okay.
It's just with the way the IBM Swift Sandbox works is it's really, really cool, but it has a little text editor in the web browser, so you type your stuff and then you hit run, and it will take your source code and put it on IBM's server, compile it with the Swift Linux compiler, run it, and then it will send you all of the output from the terminal. So you can do things like, opening files and all of those sorts of APIs, but there isn't a way for you to, get input from standard in, because it's just running in your web browser.
So if we wanted to write our program or current coding challenge in Swift, the only way to run it in this class is we need a Mac, essentially. Okay.
Yeah. Unfortunately, yeah.
So something,
Have you tried it running on a virtual Linux?
I have not played with the Swift Linux compiler, no, because I just do it on my Mac. But yeah, I would be interested in hearing if anybody wanted to either run Linux in a virtual machine, or if you have a machine that dual boots into Linux. I'd be interested to see what the Linux Swift compiler is all about, for sure. Any other questions? One last thing I'll say then, because we've got a little bit of time. Unfortunately, I don't have any coding samples for this. But in addition to objects, which we study in our courses here, Swift also has a cool concept called protocols. And with protocols, you can pretty much take anybody else's object and add an ability to it. And so if you had a string, you could set up a protocol that says, I'm going to add this method to any string. So maybe it's like I want to add the uppercase method to strings. So you just define a method that takes a string parameter and changes all of the characters to uppercase, and then you can attach that to the string type. So now anywhere in your code where you're dealing with a string, whether it's a string literal in quotation marks or a string variable, you can just have that string dot your uCase method, and now it's going to uppercase the string. I guess with uppercasing a string, it's kind of a silly example because obviously the language has things built in for that. But like with our 99 bottles of beer on the wall programming challenge that we did a while ago, you could write your entire 99 bottles of beer on the wall as a protocol and then attach it to an int. So you could run the program with just the literal 99 dot song or something. And then it'll take 99, send that as input to the 99 bottles of beer on the wall function, and just print it out 99 times or whatever. And so, and that's another thing that's cool is that, in Java, we have ways of dealing with primitives as objects. We have an int wrapper, but in Swift, that's not necessary. Anything that is a primitive is also an object or can be treated as an object immediately. So you can do just the literal 99 dot and then some protocol that accepts an int.
So, I don't know much about like the C-based
Sure.
languages or anything, but did you say that Swift is going to replace all these things, or what is it doing? Like,
So-
is it going to be like long forgotten code after?
The goal of Swift is to be able to scale all the way from low-level operating system code all the way up through, GUI applications, through server applications, to even just writing a little scripting language that, parses through a couple files or something like that. Apple really wants Swift to replace C++. It's absolutely going to replace Objective-C. If they could write an entire operating system in Swift, that's where they want it to get to. Yeah.
Okay, that's interesting.
So again, only time will tell if it accomplishes that goal. I don't want to promise that the next great operating system is going to be written in Swift, but that is explicitly the goal of the language. They want Swift to be able to be used for operating system development. So it wouldn't be like trying to take JavaScript and, well, it works in the web browser, how can we run it on the server? Well, let's just extract this JavaScript engine and now we've got node.js and we can kind of run JavaScript on the server. And, well, could we write an operating system in JavaScript? No, that would be a terrible idea. Nobody would do that. But Swift, from day one, has been, to scale that whole gamut. Any other questions? All right, cool. That's all I've got. Thank you.